So for 42, they give you the two given pieces of information, or three, whatever, five, whatever. They tell you it's released at time 0. They tell you at time 1, which is 0.685 seconds, that it's at 3 centimeters. And they tell you that at time 2, which is 0.886 seconds, whatever, it's that number, it's at, oh, there it is. It's at negative 3 centimeters. So then you're using just the basic, they're using the basic statement, if you will, that we came up with. Remember this sort of x equals a cosine omega t plus phi? Okay, so they're just going to use this twice. So they show you here, they're saying they're going to use that, and then they just plug in these things at 0. So at 0, you should get, phi equals 0. And then at the first time, they plug it in to get 3 centimeters equals a cosine 0.685 omega. And then the second one is negative 3 centimeters is a cosine this. So does that part make sense? See what they did? Yeah, all they did was just plug it into that original statement. And then, since the magnitudes of those two things are equivalent, it looks like they're just going to set them equal to each other. Right? They're just going to say that this one is equal to the negative of that one. So it seems, they're just, or whatever, I guess you could just say substitute this in for 3 centimeters, whatever, however you want to do that. And then from that, they get this statement and solve it for omega. So if we do that, I mean, I don't know if we, you can see how they plugged it in here. Just take this, put it into the t. Well, first they determined that when you put in 0 here, then x is a, so then phi must be 0. And then here they plug in the time there. With this, plug in this time there with the negative 3, and then they substitute one in the other. Yeah, I'm recording. Okay, and then from that, they get their answer of 2 radians per second. And then once you've got your omega, to find the a is pretty straightforward. Because if you know omega, then you can plug that into there and get your a, because you know the other parts. Yeah. Oops. Okay, so once again, by definition, they're saying if you pull something back and then let it go at t0, then that x of t or x at 0 is a. So when you put the t into the term, this expression here, then you get phi is 0 radians. And then we go ahead and take that expression and stuff all the variables in, substitute one into the other, and get this 2 radians per second. And then you've got all kinds of options here for the second part. Take the omega that you just got in part A, and then any of the other given information, plug it into one of those equations and get
A. Wait, where did they get the pi from? Like the cosine pi minus 0.886 omega? Where did they get the pi from?
Okay, let's see. It says, so they did this and this. So if that's equal, how do we get the omega out of here? Pi is 0.66. Is it like a identity or something?
I have no idea.
Wait a minute, that is weird. Where is that? So these two equal to each other. How do they go from here to here? Because negative cosine. Well, okay. Rather than trying to figure out what they did, well, how would we solve it if we did it? If we did the 3 centimeters equals cosine omega times 0.685, and then you have the negative 3 centimeters equals cosine of omega, or whatever, I guess I should have done it the other way around. 0.866 omega. .685 omega. Then they substituted that in for this. It looks like, so you get negative 0.685 omega equals cosine of 0.866 omega. So how do we solve that for omega? So how do you get rid of cosine? Take the
cosine inverse.
That doesn't get you anywhere though. You take the inverse cosine, like all it's gonna get you is just 2 omegas. Equals to -3.
Wait, say that again? You really like take the inverse cosine of both sides. But then that's a negative cosine, so what is the inverse cosine of negative cosine?
Separate the -1 from the
Is that even possible?
Well, I think that's why they did this. Because this is negative cosine of this. So then
So where did you get the pi from?
oh.
0.886, like.
Oh, haha, nice.
Wait, what?
They gave us this hint, which is negative cosine of theta is equal to the cosine of pi minus theta.
Oh! That's why.
That's real.
Okay. Oh, sorry. Yeah, so then that makes this much easier. Okay, and so then now they have this one as negative. Yeah, this one's the negative one.
Does it matter which one is the negative one? Because it's like in the end, it's gonna come out the same answer.
Yeah, I think so. This one is 3 equals this. I don't know. It's weird. I'm not sure. I think that way. Yeah. Well, anyways, I would substitute this one in, I guess, for that. That's how I get this. Of course. Oh, sorry. There should be an a here, but then of course the a's cancel out here, and then we can use this to say cosine of pi minus 0.685 omega equals cosine of 0.866 omega. Then take the inverse of cosine of both, and then subtract or whatever, add them up.
And then solve.
Yeah, solve it up. Okay, questions on this part? Does that make sense?
It makes more sense. And like.
Do you remember that identity from trig?
No. Oh, yeah.
This.
Oh.
you remember? Do you remember this from Tree? Yeah, this I'm trying to remember, and I can't remember that. Oh well.
That
Thank-
makes sense though.
At least the hint was nice.